dealing with 4.5, which is dilations. Dilations are not a rigid movement. What's it mean if something's not a rigid movement? Nathan? Good. There is a change in size. So, whereas flip slides and turns or rotations, reflections, and translations are all rigid movements, a dilation is not. It's going to change size. It's going to change shape. If it gets smaller, we call it a reduction. If it gets larger, we call it an enlargement. And as we're going through dilations, there will always be a center of dilation, and there will always be a scale factor. So as we're talking about this stuff today, it'll help to be able to refer back to page 114 if you want to take notes there. Okay? I want you to take a look right now at page 115 of your student journal. Okay? And on page 115, I want you to go ahead and work on problem number 1 with your groupies to the best of your ability. Okay. Hey, is it a reduction or an enlargement? How many say reduction? How many say enlargement? Okay, it's gotten smaller, right? So if we're going here, this shape down here, and then we are connecting, it's helpful if you actually hit the points, there to there, there to there, like that, and we now go to there. We've actually gotten smaller, so it's a reduction. All right, how much are we reducing? Well, we're going from our point of dilation, which is C. We're going a distance of 4 down to a distance of 2. So 2/4 is 1/2, or 0.5. All right, so what you need to know is a reduction, the scale factor for a reduction is less than 1. Okay, if you're reducing, the scale factor has to be less than 1 for a reduction. Tell your neighbor what it has to be for an enlargement then.
Greater than 1.
Good. An enlargement would be greater than 1. So if we take a look at number 2 here, we're going from this shape, okay, which is pretty easy to see, and then we are enlarging it out now to that shape where we add that extra piece on. So notice our shape now includes our original plus a little more. Okay? So we now have went from 20 to 25, or 25 to 20. We know it's going to be greater than 1, so we just make it so our fraction is going to be larger than 1. 25/20 becomes 5/4, so our scale factor is 5/4. In an enlargement, the scale factor is greater than 1. Yes? I put it in fraction form. If it's a decimal that reduces, or like 0.5 it terminates, you can use a decimal, I guess. I prefer a fraction because you're going to use that factor later on. You don't want to round any fractions. Okay? All right. Go ahead and try number 3, please. All right. Tell your neighbor what you got. All right. How many got it? You're good? I want you guys to do number 4, please. Make sure you're asking me questions as we're going around. Okay. Hey guys, this I found that this book kind of does a poor job at telling you where your center of dilation is. If they don't tell you where the center of dilation is, always assume it's at the origin. Okay, and they don't tell you that on this. So if you take and plot your point, so that's A, -4, -1B, and C. Okay, I got that plotted correctly. All right, and they're saying the center of dilation, they don't actually tell you it here, so let's assume it's always at the origin if they don't tell you. Okay, so in other words, your shape is being projected from this point right here. Okay, and it has a center dilation with a factor of 2, meaning if you look at this distance from the center of dilation to C, it's got to be twice that length away. So yeah, a good way to do that was to think of slope. So I go over 2 and down 1. I'm going to go over 2 more and down 1 more. And my point B is exactly where I need to put it. So let's, okay, that would be C prime. Okay, and then B is over 1, 2, 3, 4, down 1. So we'll go over 1, 2, 3, 4, and down 1 again. And now we have that same distance. That is now B prime. We go over 1, 2, 3, up 1. So 1, 2, 3, and up 1. And that is now A prime. Okay? And so if we were to connect our primes, this new shape is now twice the distance away from the center of dilation. Yeah, Drew.
Why is the shape moved away from where it was? So the beginning shape, it was where it was.
Right, because it's moving that distance away. It's getting bigger. Okay, by moving that distance away, it's actually enlarging the shape.
How come it's not enlarging where it is? The same,
Because your scale factor's here. In order for it to stay exactly where it is and to grow, your scale factor would have to be in the middle. Or excuse me, your center of dilation would be in the middle then. And then it would be growing where it's at.
So it matters where the center of dilation.
It for sure matters where the center of dilation is, yeah.
So if it's the origin, it's like that.
Yeah, unless the shape has to. Yeah, it's going to move. It's going to make the shape appear to move unless your center of dilation is directly in the middle. So if your shape's right over the origin, yeah, it's going to expand out that. Good question. Danica. Yeah, 3-dimensional. Pretty cool. Yeah. That's your scale factor. So that means you're that far away. So if you think of that as 1 distance away, since it's a scale factor of 2, you've got to go twice that distance. Okay? So if it was 3, you'd have to go up and over again. Yeah?
Unless it says otherwise, you always go to 0.00 as your center of dilation.
Yep. Okay. Good questions. Let's go ahead and turn to the next page, please. Okay, I want you to try number 5. Give number 5 a go. You plot the points? You'll be able to see here in a minute. All right, so there's my original figure. Correct? So we have S, R, P, and Q. And now we have a scale factor of 1/5 going from here. So that means rather than going up 5 and not going over at all, we just go up 1/5 of that, or 1. Okay, so this would be R prime. This length right here goes out 5. Rather than going out 5, 1/5 of 5 is 1. So that's Q prime. This goes out 10. 1/5 of 10 is 2. That would be P prime. And this goes up 5 and over 5, so rather than going up 5 and over 5, we go up 1/5 of that and over 1/5 of 5, which is 1, 1. So my new figure is this little guy right there. 1/5. There we got it. Pretty cool. How many got it? Neato. Any questions? Hey guys, notice what you're doing here. When you're taking, and I'm going to use point S right here as an example. S is -5, 5. And so this is going to lead us into what we're doing next. If I didn't want to draw my picture every time, I could take point S, and to get S prime, which is at the order pair -1, 1, how could I get from here to there? What's that? Yeah, divide by 5 or multiply by 1/5. If I take this point and multiply it by 1/5, that gives me -1. Or, excuse me, it gives me... Did I have that wrong? Oh, I got my points labeled wrong here. Thank you. -5, 5. So that would be -1. And I multiply this one by 1/5. It gives me 1. Okay? This is where point S becomes point S prime. So you don't have to always plot the points. You can just multiply each coordinate by the scale factor. Okay? That gives you that, and that gives you that. All right, I want you guys to try number 6 and 7 with your groupies there. Okay, hey, so you're multiplying each point by -6. So when we do that, multiply by -6. So A prime becomes 3 times -3 times -6, or 18. 1 times -6, -6. B prime becomes -4 times -6, or 24. And -1 times -6, or 6. C prime becomes -2 times -6, which is 12, and -1 times -6, which is 6. There you got it. Yeah, Moonty. Reduction? It's not, no, it's not necessarily absolute value, no. So, because you can, just because they were negative, that doesn't necessarily mean they're going to be positive values, or vice versa. All right, I'm going to go ahead and put up the answers for the next ones there. You multiply it by 1/4, or -1/4. You should get P prime is 2, -1, Q prime, -5, 2, and R prime, -4, -1, S prime, 0, -3. If you quit playing with your pens, you'd be done. Okay? All right, we'll do the other two a little later. Actually, the last two, number 8 and 9, those are going to be part of your assignment tonight. So I want you to do number 8 and 9. You can working on those right now. I'm going to hand out the rest of your assignment here as well. Okay? Very good.